Hello friends, welcome to VK Lectures. In this video, we are discussing the question number 47 from Karnataka set 2024. The group of order less than 4 is, now let's see the options, always cyclic, may or may not be cyclic, always non-cyclic, cyclic under some condition. Now let's see what is a cyclic group. Cyclic group is a group that can be generated by a single element. That means all the elements in the group can be generated by that particular single element. That means that there exists an element G which belongs to the group such that every element of the group can be written as power, that is the multiplicative notation or addition of G, such that G to the power n, this need not be always power, it can be additive also. Now for example, in addition, that means if the operation belonging to the group is addition, G to the power 2 means G plus G. If it is multiplicative, G to the power 2 means G into G. Okay, where n is any natural number and G to the power n belongs to the group, and this G is called generator of the group, one which generates all other elements in the group. That is why it is called generator to the group. Now coming back to the question, group of order less than 4 is, it is always cyclic, because a group should consist of, any group should consist of the element its inverse, identity element, okay, in specified operation, in a given specified operation, the element its inverse and identity element. Now these three you can write it as A as an element, E as the identity element, and A inverse as the inverse element. So these three will constitute all the cyclic elements. From one you can get the other elements, but if there are one more element, fourth element in group, then this group may or may not be cyclic. So up to 3 the group is always cyclic, but after 3, that means if the group consists of more than 3 elements, example 4 elements, then the group may or may not be cyclic. Now here we have the different orders of the group 1, 2 and 3, corresponding elements in the group E, EA and EA A square. In the first case there is only identity element E, which means E dot E is equal to E. E is our element and E itself is the inverse, and this E will be the identity. All are same. So when you multiply or when you do the operation on E, you get E. So you get the same elements back. So it is cyclic. Now in the case of EA, you get A into A equal to E, or A square equal to E. The first one is the element. Here you have the identity element, and A itself is the inverse. So this is the element. This becomes the inverse of the element. A itself is the inverse of that particular element, where you get identity element, which is E for the case of order 2. Now in the case of order 3, you have E, A and A square. Now E is the identity element, A is the element, A square is the inverse. This is identity and this is the element. A into A square, what you get, you should get E. So in the case of this order 3, A square is the inverse, as well as A square is the generator also. That means with A square you can generate other elements in the group. So A into A square you give E, E into A square gives you A square, A square into A square gives you A. So you get E, A square and A, E, A and A square using the generator A square. So A square is generator as well as inverse. Further, A is also a generator. A or A square is the generator. How is A generator? E into A gives you A. Now A into A gives you A square. Now A square into E gives you A square into A. Sorry, A square into A. A square into A gives you E. So you have A square and E. You got all the three elements in the group using A. So this is how you mention as cyclic. So A is also a generator, A square is also generator for the elements present in group of order 3. Now there is a important statement that if the group order is prime numbers 2, 3, 5, 7, etc., prime numbers, then it is automatically cyclic. So if there is any group of order 5, it is cyclic by nature. Now here is an example of group with order 4, which is cyclic. So generally for order greater than 4 or 4 or more than 4, it may or may not be cyclic. So actually the answer for group 4 is may or may not be cyclic, as we discussed. And here is an example of cyclic group with order 4. Now operation is addition mode 4. Now what is this addition mode 4? Addition with mode 4, which automatically indicates if the element you get after the operation is 4 or greater than 4, its remainder is taken. Taken as the element. Nothing. If you get 4, 4 divided by 4, the element remainder is 0. So it goes back to 0. So if I add 0 plus 1, 1, plus 1, 2, plus 1, 3, plus 1, 4. Instead of 4, again it goes back to 0. So everywhere 0 by 4, 0 by 4, by 4, by 4. What is the remainder? Always remainder is 0, 1, 2, 3. So it is like this. For mode 2 means it can count up to 2. So 0, 1, after 1 you should get 2, but 2 divided by 2 is 1, so remainder becomes again 0. So 0 plus 1 is 1, 1 plus 1 is not 2, it is again going back to 0. Okay, so this is mode 2 and this is mode 4. Now here we have a generator, which is a generator. It will be cyclic only if it has a generator. If the generator is 1, because you add 1 to 0, you get 1, and then add 1 to 1, you get 2, and from 2 you add 1, you get 3, and after that again it will go back to 1. So it becomes a cyclic group. So this is an example of additive group with order 4, which is cyclic group. Okay. Now here is an example of group with order 4, which is not cyclic. So it's clear that with group 4 you can get a cyclic group or you may not get cyclic group. Here is an example of a group with order 4 which is not cyclic. This Klein 4 group. This is also called a Klein 4 group. The 4 represent only the order of the group. Now here is the elements in the group. So it's an addition with mode 2 with coordinate wise. Coordinate wise. Now what is it? So V4 is a group of 0, 0, 1, 0, 0, 1 and 1, 1. Now the operation is component wise addition with mode 2. Now to understand this, let us look into the properties of the group. It obeys closure property. Sum of any two pairs is again in the set. So you add any two groups, it will again belong to the same group. For example, 1, 0 and 1, 1. 1, 0 and 1, 1. 1, 1 you get 2. 2 divided by 2 is 0. And 0, 1 you get 1. So 1, 0 and 1, 1 gives you 1, 1. Similarly, you take 0, 0 and 1, 1. You get 1, 1, which is again in the group. So mode 2, please remember this. Okay. Now that is set. For identity, it is 0, 0, which is an identity element in the group. You add 0, 0 to any element in the group, you get the same element, which is nothing but the identity element 0, 0. Now the inverse for every element has its own inverse. For example, the first case, 1, 0 plus 1, 0, you get 0, 0. 0, 0 is our identity element. So 1, 0 and 1, 0, you get 0, 0. So this element has its inverse 1, 0, which is again is in the group. Similarly, 0, 1. What is the identity element for 0, 1? 0 1, let's see, for 1 1 you get 2 which is 0, and 1 1, that is 1. It has to be 0, I guess. Yeah, it's 0. So 1 0 1 0 1, you get 0 0. I hope it's clear. So 0 1 has its inverse as 0 1 itself. You get identity element 0 0. So which is again in the group, and associativity, which is again, it's an addition property which will be again in the group itself. Okay, so it follows the properties of a group. For any elements in the group, it should follow some properties. So it has closure property, identity, inverse, and associativity. Now, why it is not cyclic? You take any element, the entire set of group of these elements cannot be generated. For example, 1 0, you take 1 0, add 1 0, you get the identity element 0 0, but again you add 1 0, you get 1 0 only. After adding 0 0, then again if you add, you get 0 0. So other elements in the group such as 1 1 you cannot get. So it's a case of any element in the group. Either you take 1 0, you can generate only 2 elements. Again 0 1 also we can generate only 2 elements of the group. Take 1 1, it can generate only 2 elements. For example, 1 1, if you add, it becomes 0 0. You add 1 1 1 1. 1 1 gives you 2, 2 mod is 0, 1 1 again 0. So it gives you again 0 plus 1 1. Again you get 1 1, not any other element. So no any element can generate all 4 elements. So it does not have any generator. Generator is not present for this set or group. Now thus this is not cyclic. So Klein 4 group is not cyclic. It's an example of group with the order 4 which is not cyclic. Here are some of the questions for you to practice. Please comment your answers in the comment box with the appropriate question number.